After having discussed the scenario-based intuition, let's move on to define the components of the automaton auth psi associated to a formula psi. By the way, this formula psi will be fixed all throughout the following discussion. As mentioned before, the automaton's alphabet sigma is the power set of the set of atoms. To define the other components, we first define the closure of psi to be the set of all subformulas of psi and their negations. Here are some examples. The closure of an atom A consists of the atom A and its negation. The closure of always A consists of A, not A, always A, and not always A. The closure of always eventually A consists of A, not A, eventually A, not eventually A, always eventually A, and not always eventually A. The closure of this more complex formula, always, not always A or B, consists of A, not A, B, not B, always A, not always A, and so on. So we pick all its subformulas and we take their negations as well. Something to note here is that even though not always A is a subformula of this big formula, we did not consider not always A in its closure. Remember that we identify a doubly negated formula with the formula itself. So not always A is just always A. This is why we didn't have to indicate not always A explicitly there. Let's now define the set of states Q. Q will consist of subsets of the closure of psi. So will contain subformulas of psi and negations of subformulas of psi. Namely, Q will consist of those subsets that are elementary, where elementary captures formally our previous discussion about complete and consistent scenarios. More precisely, elementary means complete and propositionally and temporally consistent. Where a set K is said to be complete if for each formula phi in the closure of psi, it contains either phi of its negation. So K contains either phi or its negation. So it decides whether phi should be true or false in that particular scenario. Moreover, K being propositionally consistent means consistency with respect to the propositional connectives. If the scenario K contains phi, then it should not contain not phi. It should contain phi and it should contain phi 1 and phi 2, just in case it contains both phi 1 and phi 2. It should contain phi 1 or phi 2, just in case it contains either phi 1 or phi 2. And it should contain phi 1 implies phi 2, just in case containing phi 1 implies containing phi 2. Time to pause for 3 seconds and think of what these consistency conditions remind you of. Of course, they remind you of the semantics of formulas, because they essentially mimic the way the satisfaction relation is defined. And this is not surprising, given that the scenarios refer to what's true and what's false on some presumptive infinite sequence. So consistency really refers to obeying the properties of the satisfaction relation. And we have a similar situation for the temporal connectives, where the notion of temporal consistency mimics their semantic properties. Of course, if always phi is part of the scenario K, then phi needs to be part of it as well, because always supersedes now. On the other hand, if phi is part of a scenario K, then eventually phi should be as well, since now supersedes eventually. For until, we have two conditions. First, phi 2 being part of the scenario forces us to take phi 1 until phi 2 in the scenario as well, because phi 2 being true now means that phi 1 until phi 2 must be true as well. On the other hand, if phi 1 implies phi 2 is part of the scenario and phi 2 is not part of the scenario, then phi 1 must be part of the scenario as well, since according to the semantics of until, phi 1 must stand as a guard until phi 2 is true. Okay, in conclusion, Q consists of all the scenarios for the truth or falsehood of the subformulas of phi, which are complete, of the subformulas of psi, which are complete in that they don't miss any subformula and are consistent in that they do not contain contradictions. Note that consistency here only addresses the local aspect in the current state. While this is sufficient for propositional consistency, in the case of temporal consistency, we'll also need to look into two more things, reflecting our previous discussion of unfinished business. What happens when moving from the current state to the next state, and what happens on the long run along the sequence. For example, it's good that we require that always ensures now, but this is not sufficient, because always refers not only to now, but also to everywhere in the future. Another thing to note is that these conditions so far do not refer to next. This is because, from the point of view of the current state, there's nothing to say about next. But we are going to have things to say when we move to define the transition relation. So, the aspects that I mentioned last, namely the long-term behavior and the question about what's happening next, cannot be addressed by the automaton's set of states Q, but will be addressed by the transition relation and by the set of accepting sets, which we have not defined yet. Now let's define the set I of initial states. This is simply the subset of Q consisting of those sets K in Q that contain psi, meaning of those scenarios K where psi itself is true. The reason for this choice of the set I is the following. Our automaton, auth psi, is supposed to accept only the atom set traces of sequences satisfying psi. Consequently, the initial states, where all runs must start, should only plot scenarios where psi holds. Here's an example taking the formula psi to be always eventually A. The set Q contains 5 states, and the set I contains only 2 of these, which have the formula psi in them, the ones shown in blue. These 5 sets are the scenarios that we discovered before by analyzing all the consistent ways to make the subformulas true or false for always eventually A. The same sets are of course obtained if you apply the general definition to this particular case. As an exercise, please revisit the definition of Q from before and check that this example is correct, in the sense that these are indeed all the elementary subsets of the closure of always eventually A. Moving on, let's define the transition relation. And for this, let's keep in mind that sigma is the power set of atoms. And Q is a set of sets of formulas. And that the sets of formulas that belong to Q represent scenarios. So let A be a letter, in other words, a set of atoms, and let K, K prime be 2 states, which are sets of formulas. We define the notion of K transiting to K prime via A by the following conditions. First, A is the intersection of K with a set of atoms, meaning that A consists of exactly the atoms in K. K may contain other formulas as well, and atoms, and A will consist of exactly the atoms in K. So A is a set of atoms that are true in the scenario represented by K, which makes A a valid labeling at that state for a presumptive infinite sequence. Remember that our goal for our automaton auth psi is to accept atom set traces of such sequences, which are nothing else but sequences of atom set labelings. Second, we require that the following conditions hold concerning the temporal connectives. For any formula phi, such that next phi is in the closure of our fixed formula psi, we have that next phi is in K if and only if phi is in K prime. For always, we have always phi is in K if and only if phi is in K and always phi is in K prime. For eventually, we have eventually phi is in K if and only if either phi is in K or eventually phi is in K. And for until, we have phi 1 until phi 2 is in K if and only if either phi 2 is in K or phi 1 is in K and the until formula persists into K prime, so is in K prime. To understand these conditions, think of K as the now scenario or current state scenario, and think of K prime as the next state scenario. With this in mind, we can see that all that the conditions do is make sure that the transition of now into next takes place consistently. For example, of course that if our now scenario has next phi true, our next moment scenario should have phi true. Also, eventually true in the now scenario means that either phi is already true in this now scenario, thus closing the matter, so to speak, or eventually phi will still be true in the next moment scenario, in which case we postpone the unfinished business of eventually making phi true. And similar intuitions hold for the conditions for always and until. Please pause the video for a short while and think about these conditions. Okay, we have one more component to define, namely calligraphic F, the set of accepting sets. This will consist of one accepting set for each formula in the closure of psi, which is either an always formula, that is a formula having always as the top connective, or an eventually formula, or an until formula. In each case, the associated accepting set will be called the fulfillment of the given formula. So have fulfill of always phi is the fulfillment of the formula always phi, and so on. What are these fulfillment sets? The fulfillment of an always formula, say always phi, consists of all those scenarios K that contain always phi if they contain phi. In other words, if phi is in K, implies always phi is in K. And the fulfillment of an eventually formula, say eventually phi, consists of all those scenarios K that contain phi if they contain eventually phi. Finally, the fulfillment of an until formula of the form phi 1 until phi 2 consists of all those scenarios K that contain phi 2 whenever they contain phi 1 until phi 2. Why have I called these sets fulfillments? Because they represent the long-term fulfillment of an unfinished business aspect associated to each of these types of formulas. What do I mean by that? For example, say eventually phi is part of the now scenario. By temporal consistency, we have that either phi is in the now scenario, in which case the promise of eventually phi has already been fulfilled, no unfinished business here, or alternatively, phi is not part of the now scenario. So eventually phi will be postponed to the next scenario on the sequence. So let's call the now scenario k and the next scenario k prime. But how long can this be postponed? Well, we can postpone it for a while, but not infinitely. It must be the case that phi should be fulfilled in some scenario further up in the future. Say we postpone from k to k prime, then from k prime to k double prime, but at some point, let's say here, phi must become true. This leads to the following accepting set behavior. Infinitely often on the sequence, eventually phi being in a scenario at the considered point in time should imply that phi itself is also in that scenario. So this explains the fulfillment of eventually phi. And similar explanations work for the choices of the fulfillments for always formulas and until formulas, reflecting the long-term expected behavior of these connectives. Again, please pause the video and think of how these explanations might go for always formulas and until formulas, similarly to what I have just explained for eventually formulas.